Hi there, my name is Frédéric Gontier. I'm one of the two academics in charge of this webinar series, and I will begin with a very brief opening statement. I will not tell you whether God did or did not save the kings. I'll leave this privilege to Sophie and Arnaud. Just this opening statement to greet the audience and to remind that this webinar series is meant to promote great scholars and research programs that are carried out in Sciences Po's research labs, beginning with the CESICE. So even though she's a newcomer to the CESICE, Sophie Panel is already an accomplished scholar, and a special webinar thus for her and her work makes perfect sense. And without any further ado, let's get to it and give the floor to Delphine.
Thank you very much, Frédéric. So I'm taking this opportunity to really warmly welcome, even if it's virtually for now, Sophie to the CESICE. We're very happy, and I personally am very happy that you chose to join the CESICE. The CESICE is a research center which is pluridisciplinary. We have, the main focus of all the researchers in CESICE is international security and European questions, including external European relations. And it's a research center in which we have colleagues working in international law, European law, of course, political science and economics. So I think it's going to be a good opportunity for you to present your work and to develop new work with us in CESICE. So we are really thrilled to welcome you. And without further ado, I think it's important to let you enough time to develop all your arguments, but again, you are very welcome at CESICE, and I wish that the pandemic will soon be over so that we can have a proper welcome, but in face-to-face mode.
Someday, hopefully. Okay, should I start? I guess, yes. Okay, thank you very much for the introduction, Frédéric and Delphine. Thank you very much for to the organizers to give us this opportunity to present our paper, which is going to be probably the last time because we are pretty close to submission actually. So any comments are very, very welcome because yeah, it's time to incorporate them. Thank you as well to Arnaud Books who accepted to discuss the paper at the end of this presentation, and thank you for the audience for being there and for attending the presentation of the paper. So the paper is called God Did Not Save the Kings, and this is a joint project with Antoine Pietri from the University of Montpellier. Antoine is there in the audience and will probably join the discussion afterwards by chat or by video conference, I don't know. Maybe a quick word about the chat. So the paper is a little bit technical. There is a lot of technical empirics. So if you want to ask questions, I mean, I try to make the presentation as easy and smooth as possible, but if you have any question, if there is something that you don't understand during the presentation, then you are free to ask questions using either the chat or using the Q&R thingy that you can see here at the bottom of the screen. So yeah, any questions are welcome, and I will try to address them one by one in case there are misunderstandings. So I will try to share my screen. I hope that you are all able to see the slides. Yes, okay, that's good, because if you can't see the slide, it's going to be a little bit problematic because there are a lot of table and figures. But okay, anyhow, let's start. So to give you briefly the highlights of the paper. Okay, wait a second. Sorry. Yeah. So to give you the highlights of the paper, so to put it simply, we investigate the impact of the 1982 Falklands War on the population dynamics of king penguins breeding at the Falklands between 1963 and 1997. We use a method which is called interrupted time series analysis. So we proceed in 2 steps, which I will explain in more details afterwards. So the first step, we make a simple single group ITS on the period from 63 to 97, and then we complement this analysis using a synthetic control, which we include in the original ITS So it's called a controlled interrupted time series analysis. The main result of this analysis is that the war has led to a strong decrease of the growth rate of the king penguins populations of the Falklands. So to give you an idea of the magnitude of the results, so we find that the population, the king penguin population by the end of the investigation period would have been at least 50% higher in the absence of the war. So this is a very conservative result. Actually, the point estimates are much higher. So before I start with the presentation of the paper per se, I will briefly explain why we chose to focus on this particular case and this particular species. Maybe stop this for the time being. Okay, so first, why did we choose the Falklands War? So we have several reasons why we chose to focus on this particular case. So first, it is a conflict that had absolutely no environmental causes, which means that we can avoid reverse causality issues. The second advantage of the case is that it was a unique event, which has absolutely no precedent locally. And this is also one of the rare instances of conflict that did not relapse afterwards and that did not spill over to the neighborhood, which means that we can have a clean comparison both in space and in time. So this is pretty important. And finally, it was a conflict that was technologically heavy in terms of conflict technology and material use and so on. But this conflict did not have any political or economic repercussions locally, which is also quite important for reasons that I will explain later. So second, why king penguins? I will show you what a king penguin looks like. So this is, this is a king penguin, okay? So why king penguins? So the idea is that if significant ecological damages occurred at the Falklands as a result of the war, then these damages are going to be reflected in the trends of king penguin population. Why? So first, because this is a species that is at the top or near the top of the food chain, meaning that all the damages or the changes that occurred at lower levels will be reflected in the population dynamics of this species. Second reason, they are particularly vulnerable to ecosystem damages. So for several reasons. First, because they are dependent on the availability of a particular kind of food. So if this kind of food is lacking, then they are going to starve. Second, they do not migrate, so they are unable to relocate in case their colony becomes unsuitable. And third reason, so they do not fly, so they are slower than flying seabirds, and this means that they are particularly dependent on the quality of their local, very local ecosystem. A related advantage of the king penguin, so this is a long-lived species with a low reproductive output, meaning that the population does fluctuate, but I mean, it does not fluctuate as drastically as other marine species, especially. So think about fishes, for example, meaning that we are still able to identify a signal within the noise. So that's the reasons why we chose to focus on that case. So a word about the previous literature and how we contribute to this literature. So the first contribution is like about the case selection, to put it simply. So most of the research to date does find an effect of warfare on the environment, a negative one mostly, but most of this paper focus on civil wars, and most of these papers also focus on terrestrial ecosystems. So what we add is that, to put it simply, we have another type of conflict, international wars, and we also have another type of ecosystems, marine ecosystems. But the most important contribution that we make to the literature is a contribution about causal mechanisms. Most of the research to date finds that the negative effect of the war is due to the economic and political changes that follow wars. So, for example, the fact that there is no money for conservation initiatives, or the fact that people have to resort to poaching for survival and so on. So that's the main causal mechanism that the literature identifies. And another conclusion is that hostilities per se or the use of war technology does not have a direct impact of the environment. So that's the conclusion, but we think that this conclusion is maybe driven by case selection, yeah, because of the overwhelming focus on civil wars, for example. So again, that's the main advantage of our case selection, is that we are able to find a case in which the war did not have any political or economic repercussions locally. So we are able to isolate the direct impact of conflict technology. So a quick word about the Falklands War. So the Falklands War took place between the UK and Argentina between April and June 1982. So it was, and it ended with a British victory, as you probably all know. It was a relatively quick war, but it was a war that was pretty intensive. So it resulted in about 1,000 fatalities. And in terms of material and conflict technology, so it involved a dozen of shipwrecks, some bombings, some land battles, and a lot of landmines, to put it very quickly. As you can see on this very ugly map, so, the King Penguin colony is located at Volunteer Point, which is situated at the northeast of the Falklands. And importantly, this colony was not directly exposed to the war. It wasn't exposed to the battles per se, but it was probably exposed to indirect consequences of the hostility, the most important of which is probably oil spills resulting from shipwrecks. So, yeah. Now the outcome variable. So our outcome variable is the population size of king penguins expressed in breeding pairs. So breeding pair is basically a couple of penguins that produces a chick. So this is a standard counting unit in the literature. So it's our main unit of analysis. We use various sources like scholarly articles, public databases, and reports to rebuild a time series from 63 to 97. And thereby we run into three different kind of difficulties. So the first problem that, the data part is the tricky part of the paper more generally. So the first difficulty that we had is that estimates were sometimes expressed in different units. So mostly it was breeding pairs, but sometimes it was a count of adults, and sometimes it was a count of chicks. So we had to convert these estimates on the basis of the literature, obviously, but sometimes the conversion was pretty problematic because we had to assume stable conversion rules. So for example, it can be problematic, for example, if the war had led to a difference in reproductive success before and after the war. So if we rely on counts of chicks, so this can be, then we would have a systematic error. Second problem that we had, we have a lot of missing values, as you can see here on this graph. So missing values represent approximately half of the time series for the Falklands. We fill these missing values assuming a geometric growth rate, but again, this is a problem. And the third problem that we had is the quality of the data more generally, in terms of reliability. So the data is not always systematic census data. And even if the data is coming from a census, it is also prone to error because the king penguin has a peculiar breeding cycle, which means that it's impossible to find a point of time where the totality of the population is present at the colony at the same time, meaning that if you are trying to count the population, this population will be, the resulting count will be drastically underestimated with an error that can be as high as 50%. So this is a problem that we try to address using the simulation. I will talk about this later. So that's, was the outcome. So as you can see from this figure here, the population is growing. It's like there is even a strong growth rate. The growth rate is somewhat higher in the period before the war, which you probably cannot see clearly on the figure because the growth rate is geometric, so the difference is not that clear, but the growth rate during the pre-event period is about 15 to 20%, if I remember correctly, and it's more like 10% afterwards. But obviously, we cannot know at this point whether the change in the growth rate is due to the war or to other factors. So this is the question that will be clarified after the empirical analysis. So I hope that everyone is still here. Okay. No questions. Is there a question? No. Good. Yeah. Sorry. So the method. So we rely on a method that is called interrupted time series analysis. So this is a typical method for analyzing longitudinal data. So the principle is quite simple. You collect data before the event of interest and then after the event of interest, and then you see whether the event has led to a significant change of trend, which is exactly what we are trying to do here. And then in the second step, you use the pre-treatment, the pre-event trend to reconstruct a counterfactual, which shows you what would have happened in the absence of the event. So you build a counterfactual basically, and then you compare the trends of the real, you compare the real and the counterfactual path of the outcome, and then this gives you an idea about the effect size. So in technical terms, so this is the model that we estimate. So the outcome variable is the number of breeding pairs in each year expressed in a logarithm. So because we do not have a linear growth. The first coefficient is the intercept. So beta 1 is the number of years. So the variable t is the number of years elapsed since the beginning of the study. The variable war is the number of years elapsed since 1982, so since the Falklands War. And the last term of the equation that you see here are the coefficients associated with the covariates. So I will talk about the covariates now. We attempt to control for the effects of climate change. Why? For two reasons. First, because climate warming has been found to have negative effects on both the adult survival and the reproductive success of king penguins. So this is a strong result from the prior literature. And second problem, climate change has intensified since the 80s. So this is potentially a bias in our analysis. So we use two indicators, which are again pretty common in the literature. So the first one is a global indicator. It's called the Southern Oscillation Index. And yeah, it's an indicator which is associated with a broad range of climatic features. And the second indicator is a local one. So that's the average sea surface temperature. And okay, a word about the sea surface temperatures. The main mechanism that link the warming of sea surface temperatures and to king penguins, adult survival, and breeding success is food availability. To put it simply, the warmer the sea surface temperatures, the lower the food availability. So we tried to identify zones in which king penguins of the Falklands forage. So we ended up with 3 different zones over which we measured the sea surface temperatures. So a small one, a large one, and a medium one, so to speak. So yeah, 3 zones over which we measured SSTs on a monthly basis. And a final thing, so we had to account for the delayed effects of chick mortality. So meaning that the indicators, so Southern Oscillation Index and sea surface temperatures are lagged. So we have up to 8 lags because 8 years is the time that king penguins take to reach maturity. So to recap, we have 2 indicators, we have 3 different zones, and we have up to 8 lags. So this yields 243 possible combination of variables, which we tested in different specifications. So yeah, we computed basically 43 models. And then we selected the best model on the basis of the AIC corrected for small samples. So that was for the technical details. So I won't show you the regression tables, but that's the first visualization of the results. So the black solid line, which you see above, below, is the trend of that's the real trend of the outcome, so to speak. So that's the fitted values of the real population. And the 2 dashed line that you see are the counterfactuals. The size of the effect is pretty hard to identify here because of the logarithmic scale, but we find, so to give you a hint about the size of the effect, we find that the number of breeding pairs would have been about 1,700 in 1997, so by the end of the investigation period, instead of 345. So if we take the point estimate of model 1, so that's what you see from the black dashed line. If we take the lower bound of the 95% confidence interval, which is represented by the gray line, the predicted number of breeding pairs in 1997 would have been 539, which is more than 50% higher than the real number. So again, conservative estimate, but still quite large effect. 2 more remarks about the main results. So the coefficient associated with the war is always significant in all of the 243 models. And the magnitude is relatively stable across specifications. And on the side note, we also confirm the negative effect of climate change in the case of the Falklands. So the coefficient associated with the sea surface temperatures is always negative and significant. So yeah, so that was for the main results. A side note, I don't remember at which time I started. So if I talk too much and if I run over time, so please send me a message using the chat. Because yeah, I think I started like 20 minutes ago, but I am not sure. So the first analysis indicates that the war did hurt the growth of the king penguins population. We complement this analysis using, okay, no, are there questions? No questions, good. Don't hesitate if there is something that you don't follow. So this first analysis shows that the war did hurt the growth of the king penguins population and that the effect is quite large. But single group ITS has some limitations that we will try to address. So the main weakness of this type of analysis is that the change that we observe might be due to confounders, like, for example, events or trends that occurred more or less at the same time as the war, as the event of interest, but that we did not observe or were unable to observe for some reasons. A typical example here, it is possible that the number of predators of king penguins has increased during this period because of better environmental protections, for example. But we do not have data on the numbers of predators, so we cannot control for that. So a solution to address this problem is to use a control group, meaning typically here another king penguin colony, which was not exposed to the events of interest, meaning the Falklands War, but which was plausibly exposed to the same time-varying confounders as the Falklands population. But the typical question that you have to address here is what is a comparable control group? So in the present case, for example, we were able to gather data for 13 other king penguins colony. So all of these 13 other king penguin colony would be potential control units, but none of these is a priori perfectly comparable. So the approach that we chose here is to use a synthetic control. So a synthetic control is basically a weighted average of the values of the outcome variable in control units that were not exposed to the war. Okay, to put it a little bit differently. So the synthetic control, the aim of the synthetic control is to resemble the real case as closely as possible during the pre-event period, and then to compare the trends after the event to see whether there are significant differences. So as I said, the synthetic control is a weighted average. So the weights are, there is one weight per control unit, and the weights are constant for the whole investigation period. So the weights are computed so as to minimize the difference between the real case and the synthetic control before the event. And then you use the same weights to rebuild, to project, so to speak, the trajectory of the outcome after the event. So how did we build the synthetic control? So as I mentioned earlier, we were able to gather data for 13 other colonies from 5 other subantarctic islands. We do not have an exhaustive sample of all king penguin colonies of the world, but we have a quite diverse sample in the sense that the locations are pretty diverse. So it's quite representative in terms of locations. And another advantage of this case selections is that most of these islands are very remote. They lie very far away from the Falklands, meaning that there is no possibility, for example, that the Falklands War had an effect on these control cases. So a word about the construction of the synthetic control. So I will try to share my screen again. So yeah, so that's this is the synthetic control that we built. So we use data from, we selected data from 3 colonies which are situated respectively at Possession Island and Heard Island. And this is a visual comparison of the real Falklands and the synthetic Falklands. So the synthetic Falklands are represented by the dashed line and the real Falklands by the solid line. So note that it is no longer a logarithmic scale. So this gives you maybe a hint about the possible effect size. So the value of the counterfactual is much higher after the treatment than the value of the real case. And also importantly, the values of the value of both time series are pretty close before the event, which gives us a confidence that that the real case and the counterfactual case are comparable. So that's the model that we use for the control time series analysis. So it's getting a little bit more complicated than previously. So we estimated the following equation where the outcome variable is still the same, so that the logarithm of the number of breeding pairs. T is still the time elapsed since the start of the investigation period. So real is a variable, it's a dummy variable that takes on the value of 1 for the real Falklands and 0 for the synthetic Falklands, so for the counterfactual. Post 82 is the same as before, it's the time elapsed, the number of years elapsed since the war. Real T is the interaction between T and the real, and war is the interaction between real and post 82. So this is the coefficient of interest, that's the variable that measures the effects of the war. So that's what is the take-home message. So that's the main result. So please only look at the first model, because the other columns are sensitivity analysis, and I won't explain them. So to start with the most important thing, so the coefficient associated with the war is negative and significant at the 10% level, meaning that the war has led. So again, it's a confirmation of the previous results. Other important things, so the coefficient of the variables real and real T are not significant, meaning that there is no significant difference between the real Falklands and the synthetic Falklands before the war, meaning again that the real case and the counterfactual case are comparable. And one last thing, the coefficient of post-82 is not significant either, meaning that there is no significant change of trend in the counterfactual Falklands. Yeah. So in terms of magnitude, so maybe I will briefly explain what this graph is. So this graph is basically a synthesis of all the results of the test that we did in the paper. So it's simply the coefficients with the 95% confidence intervals. So the black triangle that you see at the top of the graph is the result of the main analysis, so the single group ITS. And the white circle below corresponds to the coefficient that we obtained for the controlled interrupted time series analysis. So as you can see, the coefficients are quite similar in terms of magnitude. I won't detail all the tests. I will just briefly address the one that is represented by the black square, so the fifth coefficient from above. So this coefficient represents the results of the simulation that we run in order to address counting error in king penguins population. So this is a point that I addressed earlier in the paper as I was speaking about the data. So again, there is a severe underestimation problem in king penguins population data because of the breeding cycle of the king penguins, meaning that the population is never present at the colony at the same time. So, and again, counting error can be as high as 50%. So we addressed this issue with the simulation. So basically we generated 6,000 alternative time series in which each data point was multiplied by a random number lying between 1 and 1.5. So, and then we run 6,000 iterations of the main model. So what we find is that in all 6,000 estimations, the coefficient with the war, the coefficient associated with the war remained negative and statistically significant. So meaning again that our main results are confirmed and they are not driven by random error in the data. So I will stop now because I think that I am running over time. So to conclude briefly, we find with the paper that the Falklands War had a big negative effect on the growth rate of the king penguins population locally. So the main implication is that warfare does hurt the environment, even in the absence of long-term economic or political effects. Two limitations. The first limitation is due to data quality, and the second limitation is more a problem of external validity. So we are pretty confident in our results, but we do not know whether these results can be generalized to other types of conflicts or to other types of species, because we chose to focus on the conflict that was technologically heavy and a species that might be particularly sensitive to environmental disruptions. Thank you very much for your attention. Arnaud, I don't know if you want to start.
Yeah, probably yes. I will start. Okay. So good afternoon. Thank you for being here today. Hello, Sophie, and thank you for asking me to discuss your paper. Hello, and thank you to the organizers for the webinar, and congratulations for launching this initiative, which is very welcome in these strange days. My name is Arnaud, and I'm an ecological and institutional economist, and my research is mainly dedicated to water resources. So the paper entitled "God Did Not Save the Kings: Environmental Consequences of the '82 Falklands War" discusses the causal relation between war and penguin populations. So my commentary is organized in 3 points. So what do you prefer? Can I expose my 3 points in a row and we discuss after? Yeah?
Do it.
Okay, thank you. My first point is a general comment on the structure of the paper. First of all, I would like to express my interest in reading your article, which is very refreshing and stimulating, despite its important, really important technical and methodological component. And it allows to feed the curiosity for the reader, which is, I think, the first quality of a research article. So congratulations. Indeed, your article is very well structured, and the review of the literature allows to learn a lot about environmental consequences of conflicts, whether direct or indirect. The case study is well detailed and teach a lot about the Falklands War that opposed England and Argentina in '82, its origins, its development, and also its conclusion. But also we learn a lot about the dynamics of reproduction, penguin nesting, and for example, we learn that the penguin breeding cycle is asynchronic, which I ignored first. So thank you. So as for the methodological part, I'm not a specialist in regression models. Nevertheless, the second part of your article is very, very dense with methodological details supported by abundant appendices. So the file is 66 page long, which is, I confess, a little bit scary when you have to comment on it. So, but the reading is quite didactic. I don't understand exactly how it's done, but I understand why you did it. So I think it's quite good, even for a non-specialist. Thus, my first comment concerned what I would like to define as a staircase writing. At each step of the paper, a question came to my mind: how to solve the heterogeneity of the data, how to proceed without a control group, how to solve the problem of missing data, etc., and so on. And all these questions were quickly resolved. So allowing me to move on the next step and thus to the next questioning. So in the end, a few questions remained with no answer, which is a little bit frustrating to make a comment, but it makes the reading very clear. So congratulations for the way you wrote the paper. And Sophie and your co-author, sorry, for both of you. My second point concerns methodology. The case is well chosen as it allows to isolate a certain number of variables and prevent from reverse causal issues, and the treatment, as the so-called treatment, the war, is punctual. So the amount of work is impressive and the methodology clearly presented, as well as the data in the appendices. And the article articulates several tools: interrupted time series analysis for the data, regression models that take into account climatic variables, sea temperature. 5 models are selected, tested, and sensitivity tests done to evaluate errors, particularly linked to the counting of population. So I just recall the potential error is considered as 50%. So the magnitude of potential error with the data is huge. And finally, you use a control interrupted time series to solve the problem of the absence of a control group, that is to say without war, on the same space to shape what you call a synthetic control group. So on methodology, I have 2 questions, comment as you want. First, about the synthetic control. It appears that there are important differences from one colony to another. If we consider appendices he, this indicates potential huge annual variability among colonies. So could you please detail how to account for this very huge high variability in the dynamics of reproduction, nesting, and so on regarding other colonies to construct, to shape a synthetic control group, please? So my first question. Then do you want to answer, or could I?
No, go ahead, go ahead.
Okay, thank you. So secondly, it's about my second question concerned the counterfactual via the CESICE method. It seems it traduces an evolutionary perspective. So the evolution of penguin population is considered as continuous. You come to the conclusion that war has a negative effect, which is quite large. You conclude that the colony would have been 56% larger than that observed in 97. But what about the space, the dynamics of the population itself? How can you integrate the dynamic of penguins and their environment? I explain myself. If we refer to population ecology or community ecology, there is a lot of mechanisms such as ecological niche, competitive exclusion, predations, and so on, that are involved to explain the dynamics of population. And dynamics is not just nesting and reproducing pairs. So how do you integrate the internal dynamics of species? And just a question, is it possible to consider that this specific land, this specific territory cannot lead to a different rate of evolution of the population for all that reasons, just for internal mechanisms, internal phenomena regarding development of population? And my third and final point concerns the positioning of your research as few references directly echoes to environmental economics or ecological economics. So your article seems to be very specific, the case, and at the same time very large regarding its methodological dimension. The audience for this kind of paper is can be considered as large also. So my question, what is do you have some perspective for publication? As you said, it's the last step. And is your article not primarily methodological? So once again, I would like to thank you for your very interesting and well-constructed paper. Thank you for having invited me. And once again, I want to congratulate you for this very, very interesting paper. Thank you.
Arnaud, thank you very much. First, thank you very much for coming through the papers and all the gory details about the reproductive cycle of king penguins and all the methodological details. So you survived to this. So that's very kind of you. And thank you for your points. I will try to address them briefly one by one, and then maybe open the discussion to the audience. Remember that you can still ask questions using the chat or the Q&A. So your first question, so if I understand the question correctly, so you noticed that all the control groups, so all the king penguins colony have very different dynamics. So if you take a look at the growth rate and so on. So we agree. We agree that it's a kind of limitation of the paper, in the sense that maybe it's absolutely not possible to compare one colony to another. Because all of the colonies have some kind of past dependencies or internal mechanisms that make them very idiosyncratic per se. This is a problem that we try to address using the synthetic control method, which is, yeah, that's we thought that it was the best way, because if you assume that 2 or 3 colonies are pretty similar at the beginning of their development, then maybe, I mean, if you can show that for a quite long period, their population dynamics was similar, so maybe you can expect that these developments will remain the same afterwards, that the assumption that we make, maybe it's a little bit wild. So yeah, that's probably a limitation. This brings me to your second question. So the internal dynamics that are specific to the colony, can we expect that because the colony grew quickly during a period, it will still keep growing quickly afterwards? Yeah, that's probably also a limitation. I would say it's a conceptual issue of comparability. So is this possible to make comparisons in time and space with this type of outcome variables? I do not have any clear answer for that. So obviously the results that we have are tentative. So if you agree with the assumptions that comparison in time and space are possible, then you agree with the results. If you think it's not possible, then obviously the results are meaningless. I don't know. I don't know. Maybe Antoine wants to have to add something on this topic, so you can use the chat if you want to. Maybe a quick note on your second point. So you mentioned the issue of space. So we saw papers, so in the biological literature, trying to analyze whether the growth of a colony is dependent on its size. For example, are the small colonies more fragile than the large colonies? And indeed, there are results that suggest that there is a limitation, a kind of size after which the colony no longer grows, because there is competition for access to resources, there is competition for access to space, to just a place. It's not the case for the Falklands, because it's still a small colony. So we don't think that it is relevant in our specific situations, but of course it can be relevant for the control units. And your third question, so yes, we agree, lots of methods, small results. Is the contribution?
I did not say small results. I just said huge methodological component.
Yeah, for just one little case. I mean, we agree with that. That's probably one of the limitations of the papers as well, is that it's just one war, one species. So it's again a problem of external validity. What do we want to do with the paper? So we don't think that the contribution is primarily methodological. We don't think so, because we use methods that are relatively recent, but they are still pretty standard in the literature. So we did not make any innovation, so to speak. Where do we want to publish it? So we are, okay, right now we are aiming for the big generalist reviews like Nature and Science. So let's see how that works. And then after we get rejected from Nature and Science, then the question is whether we want to publish it in economics or in the natural sciences. We are not sure. That it's something that we are currently discussing. So yeah, maybe it would be more relevant to the natural sciences, because not sure again, but yeah, that's a thing that we will have to think about in the next weeks/months. Again, thank you very much for your input. I will try to see whether there are questions. So I see one question here from, okay, Mayol Kaufman. Hi, nice to meet you, by the way. Can you expand on, okay, what are the geographic location of the colonies? So sorry for not being clear. I will try to share my screen again. So the location of the colony on the map. Okay, good. So the colony, so it's called Volunteer Point. So that's the small black dot that you see at the northeast of the Falklands. So again, pretty far away from the main battles. So the closest battles were around Stanley, which is the capital, which is a little bit further south, and it's like 20 kilometers away. So again, king penguin colony not exposed, and this it's the only sizable colony, king penguin colony of the Falklands. With regard to this, I think there was a second question. Can we think of having a control group that would be close enough from the Falklands to have similar other effects, but far enough in order to not to be impacted by the war? Yeah, that's exactly what we were. Oh, sorry, you meant the colonies of the control groups. Sorry, yes, I should have put a map of the subantarctic areas. So the closest colony, okay, do not have a map right now, but to quickly answer your question, the closest colony is South Georgia, which is more than 1,500 kilometers away. So there are migrations, but no systematic migration, and it is very, very, very unlikely that there were treatment contamination this way. And the other colonies of the control group, they are even further away, and they are also quite further away from each other. So yeah, sorry for forgetting the map. Other question there. Okay, out of curiosity, how did this research question emerge? That's a good question. I mean, actually, okay, we wanted to analyze the ecological impact of wars on a more general note. And the first reflex was to do a large N analysis, but then we ran into the obvious question of the indicator. What indicator do we use? There, I mean, it's not obvious to, it's not easy to identify a global indicator of ecological damages. And then, I mean, even beyond the questions of data availability and so on, we thought that it would be more interesting on a more general note to distinguish between types of conflicts and types of ecological effects. So that's why at the end, we felt that it was probably the best way to use case studies, because we did not expect that the war in general has an effect, a sort of average effect that you can identify using large N methods. So the case studies seems to be, I mean, seems to us to be the best way to address this question. And then how did we end up with the Falklands? For the reasons I mentioned at the beginning of the presentation, like we were looking for a war without environmental causes. We were looking also for a war where you could have a sort of neighborhood, but a non-affected neighborhood, in contrast to the other types of contemporary wars. So that's how we ended up talking about the Falklands, which was not the initial idea, but then at the end it seemed to be the best way to go. Okay. Try to scroll through the questions. Okay. Someone who left, so I don't know if it makes sense that I still try to answer the question. I was curious to know if you had specific ideas about what possible conflict and impacted environmental areas or species could be analyzed through the approach you use for the Falklands. Yeah, that's a tricky one. That's a tricky one because the advantage of the Falklands is that, again, there were no precedents and there were no other conflicts afterwards, and the neighborhood, so to speak, so the subantarctic area was not impacted. Is there any other conflict that fulfills all of these criteria? We don't know. We were trying to think about it, but we do not have any clear-cut answer right now. So that's one of the problems of the paper. We cannot replicate the analysis. I mean, it will be hard to replicate the analysis using another case. So again, to probe whether the findings are generalizable or not, it's not obvious. So yeah, what are the most relevant limits to adapt your model to different wars and environments? Yeah, that's exactly this problem. I keep scrolling. So considering that the king penguin colony was not directly affected by battle actions such as targeting, did you come across potential explanations how exactly the king penguin population was negatively affected by the war? Thank you for the question. So yes, we thought about it. So we see two potential mechanisms. So the first mechanism is probably the most obvious one, is oil spills. There were a lot of shipwrecks around the Falklands during the war, like 10 or maybe 12, I don't recall the exact number. And when I say shipwrecks, it's like big boats, right? So a lot of oil spilling into the waters. And basically all of these shipwrecks occurred in the area in which king penguins forage. So as you know, oil spills are very bad for seabirds. So two types of effects. First effect, like oiling, like they have a lot of petroleum in the, I lost the word, on the feathers. Yeah, so they can no longer swim. They lose buoyancy, for example. So they are no longer able to feed themselves and their chicks. So that's the first problem. And the second problem is poisoning. Even if the amount of petroleum is small, it can still bring like heavy damages to organs like the kidneys or the liver or the stomach. So at the end, reduced life expectancy and reduced reproductive success. So that's the most obvious mechanism. The second potential mechanism is the fact that the colony was not exposed directly to the land battles, but there were flypasts during some bombing operations. And maybe the colony was exposed to noise, and flypasts are pretty bad apparently for the penguins, because it can lead, for example, to panic movements. So that's a potential short-term effect of the noise. And long-term effects, this could cause hearing impediments. And hearing impediments on the long terms are pretty bad for the penguins because they recognize themselves through vocalization. So meaning if they get deaf, then parents can no longer recognize their chicks, and the chicks are starving to death. So that's the mechanisms that we were thinking about. Probably the first mechanism is the most plausible, but yeah. Question, think of any implication for policymakers? No, actually, I do not see what the implication would be in terms of policy. Don't make wars because it's hurting penguins. No, seriously, I don't know. It's not very obvious. No, there are no policy implications. I mean, obviously, yeah, we identify a bad effect of the wars, but we all know that wars in general have all kinds of bad effects, and people still make wars. So we don't have any policy recommendations, except again, avoid wars whenever possible. I have a question about biological warfare, but I don't understand it. So if you could just rephrase the question, that would be nice.
This could be a possible implication for policymakers, so don't go with regular warfare, but go with biological warfare, so as not to destroy the environment.
I'm not sure what you call biological warfare in this context.
Like viruses?
Ah.
Impact on humans, but not on the environment.
Okay. I am not sure whether I would make this this recommendation at the end of the paper. I mean, seriously, I think like it's really factual, and it's absolutely not. I mean, we don't have any normative ideas in mind, so it's really just pure research. Like, we were trying to probe the existence of a specific causal mechanism. Is there a negative effect of wars on the environment, even in the absence of deliberate tactics to destroy the environment? So no policy implications at all. No. But thank you. That's an interesting question. One getting to implement an ecological compensation mechanism. Sure, but then you would have to come up with a kind of general measure, aggregate measure of the ecological impacts of a specific conflict, and I don't know how you could see that, but that's probably an interesting perspective for future research. Could be interesting, like having a sort of comparative indicator of, yeah. Did you consider the liability and responsibility of the states involved? Okay, in the consequences of killing penguins. Okay, no, we didn't. It's pretty difficult because then we would have to assess which party. Yeah, I mean, spontaneously, I would say both states. I mean, both the UK and Argentina, because they both deployed a lot of war technology. I mean, they had warships and they had aircraft and so on. So yeah, I guess, but I don't know. That's a good question. Okay, I wonder if there is. Okay, this question I saw. Okay, I hope I didn't forget anyone, because the chat is going up pretty quickly. So if I forgot one of your questions, so please tell me. And if there are any other questions. No further questions. Okay, thank you again very much for the invitation to the webinar, the very interesting discussion and the questions. Yeah, I'll give the mic to the organizers, maybe.
Okay. Well, thanks a lot to the speakers, Sophie panel, and to the discussant, Arnaud BUCHS. And unfortunately, we have to wrap it up there. And we'll look forward to seeing many of you in 3 weeks for the next webinar. And so that's the teaser for the next episode. And in the next episode, you will hear Sabine Seruger and Fabien Terpan who will address the issue of normative transformation in the European Union. So see all of you in 3 weeks. And thanks for being there.
Thank you very much.